Torque. The force required to balance a beam. Okay, so we have a 1 meter long ruler, and it's supported in the middle by a retort stand. A 200 gram mass is hung 10 centimeters to the right of the middle of the ruler. Where should a 100 gram mass be added to keep the ruler from rotating? So here's our ruler, and we can think of this in a couple different ways. Since its center of mass will be in the middle, and since it's supported in the middle, then we don't really need to worry about its force of gravity, because those two, because we'll consider that our point of rotation. And as a result, from a torque perspective, they will both have a radius of 0, so we don't need to consider them. So if that's the supporting force, there's some force of gravity, but we don't care actually what either of those are. Or we could just say that the 1 meter ruler probably has an insignificant mass in comparison to the other things, but since we're only dealing with the 200 gram mass and a 100 gram mass, maybe we shouldn't make that assumption. Anyway, the 200 gram mass is hung 10 centimeters to the right of the middle of the ruler. So it said that this distance is 10 centimeters, and this is a 200 gram mass. Where should a 100 gram mass be added to keep the ruler from rotating? I think we can see from common sense that the 200 gram mass will try to make this rotate this way. So we better put the 100 gram mass out on this side to try and balance it by trying to make it rotate that way. So if I put that there, then what I'm really interested in is where should I put it? What's the distance there? If I do the sum of the torques, I'm going to do them about this point right here. And what I'll get then is the radius times the force acting. I'm going to call this the positive direction for my radiuses. And so for the 200 gram mass, I will get a radius of 0.1 meters times the force of gravity acting on that 200 gram mass. Keep in mind that it's negative because it's going down. And for the other mass, plus, I don't know what radius I want to have for it, so I'm going to call it x times the force of gravity acting on that mass, which would be force of gravity equals 0.1 times 9.8, giving me a force of gravity of 0.98 newtons. Again, negative. So what I get here, if this ruler is not going to rotate, and you'll notice that I don't need to include my force of my support or my force of gravity, because for the force of support or the force of gravity, the radius is 0 because of where I've chosen my rotation point. So what I get here is a solvable equation for x, as long as I recognize that the sum of the torques must be 0 if this object is not going to rotate. Solving this equation, what I'm going to discover is that x is going to work out to be, sorry, I forgot a few negatives there. X is going to work out to be negative 0.2 meters, or 20 centimeters to the left of the center of the ruler. So if I hang the mass 20 centimeters this way, it will balance out that 200 grams. That makes sense if you look at it, because the mass weighs half of what the other one does, so it has to be twice as far from the center rotational point.